Okay, today, last time also I have discussed about the algorithm we are going to see today, that is the window viewport clipping algorithm. In that, we'll see the point clipping. What is the point clipping? Then in line clipping, we will see algorithm over Cohen-Sutherland, and for polygon clipping, we'll see Sutherland-Hodgman algorithm. So starting with the first is what is actual window and viewport transformation. So suppose this is the first figure you can see. This will be the profile. Suppose this is the profile given, and this is the window. Window you have wx max minimum and wx maximum, and similarly for y coordinates wy minimum and maximum. Then the profile which is inside this window will be remained, and other this profile will be discarded. And as you can see in this window number 3, in which the profile which is inside the window is kept, and other portion has been discarded. So this command is basically, you suppose if you consider paint, in which select and crop option. So for crop command, this clipping is used. Okay, and then we'll discuss first what is window and what is viewport transformation. So suppose again I will take the same example. Suppose this is your coordinates, x coordinate and y coordinate is given, and this is the window is given of something coordinates are given. Okay, so this will be considered as your x w minimum, and this will be considered as x w maximum for x coordinate, and for y coordinate this will be considered as y w minimum, and this will be considered as y w maximum. Okay, and a profile is given. Suppose it is of in this way. Okay, such kind of profile is given. So you can see that this portion which is outside the window should be discarded. Okay, so after discarding, so window will be to viewport means in simple language is that the viewport is the device which is to be which the profile which is to be displayed, and will be which is inside the window, that will be the viewport. Okay, so viewport will be in this way. Okay, so in this portion will be remained, and in this case this is your x, this is your, it is considered xv minimum, this is xv maximum, and this is yv minimum, and is your yv maximum. Okay, so this is your window, and is after clipping it is a viewport. This is viewport. Okay, so first in the case we are considered a world coordinate system, and then we apply the command. Suppose crop command is used to view that port, so we use the device coordinate in that. Okay, so this xw minimum, xw minimum, and xw maximum, this is for x coordinates, and yw minimum and yw maximum are for y coordinate. Okay, so it is a nothing but this it is a Cartesian coordinates So we call that as world coordinate. So we use WHA. Okay, and for x v minimum and x v maximum for x coordinate, and for coordinate x v minimum and maximum x v maximum will be called as device coordinate. Device coordinate. And this window is called as this is called as window, and this is called as viewport. Okay. Now, to calculate the points which is inside and outside the windows, we can write the equation as, suppose we have to calculate points. We have to calculate points given x, v, and y, v. Okay. So for that, normal point window equation will be normalized point window will be xw minus xw minimum. Xw, so minus xw minimum, and xw maximum minus xw minimum. And for y same, yw minus yw minimum, yw maximum minus yw minimum. Okay, this is nothing, I can explain this. This is nothing but the equation should be suppose it should be more than, so suppose x value is there given, x and y is given, and so it should be xw value, and it should be more than x value should be more than xw minimum, and it should be less than xw maximum. It should be less than xw maximum. Similarly for y, it should be more than yw minimum, and it should be less than yw maximum. So we can consider that point or the line or the polygon, it is inside that viewport. Okay, then the normalized point for viewport will be normalized point for viewport or on viewport will be xv minus xv minimum divided by xv maximum minus xv minimum. Similarly for y, yv minus yv minimum, yv minimum, and yv maximum minus y minimum. Okay, then suppose we consider this to x coordinates and y coordinates separately. Then for x coordinate xw minus xw minimum divided by xw maximum minus xw minimum. So I have used this equation over here equal to the this viewport equation, that is xv minus divided by xv maximum minus xv minimum. Okay. Similarly for y net, for y coordinate, so next they will ask you what is a window and to viewport transformation. Then you have to draw some program in this way, and you have to write down what are the general terms used in this, and then you have to write down this equation, and finally you have to plot the final matrices. Okay. Similarly for y we use for yw minus yw minimum divided by yw maximum minus yw minimum. Then yv minus yv minimum divided by yv max minus yv minimum. Okay. Then to find out the xv value, uh, then for xv value remains after solving this, you will get xv minimum plus xw minus xw minimum Sx. So Sx is nothing but the scaling factor for x coordinate, and Sy will be the scaling factor for y coordinate. So Yv will become Yv minimum plus Yw minus Yw minimum. Okay. Then Sy. Okay. So also for Sx value, you can use Sx equal to find out the Sx value if the problem is given. Then xv max minus xv minimum divided by xw max minus xw minimum. And for Sy, yv max minus yv minimum divided by yw max minus yw minimum. So if we convert this into a matrices form, then what will be the equation in matrices? It will be Sx 0. So in the scaling matrices, you have to use same type. So Sx Sy 0 0 0. Then this equation of xv instead of x, this x equation, and instead of y, you have to use y equation. So you can write there. Then in the problem you can solve this and write the values and solve the problem. So Sx minus and y v mean minus Sy, or you can write yw first and then also. So in this way you can solve the problem. We will take a simple example over this equation. So suppose a window for a window is given. That is values given are xw minimum value is 20, xw maximum value is given 80 units, And similarly, y values are given. Suppose this is our coordinates. This window is given. So this is your x w minimum is given, that is of 20, and maximum is given is 80. Maximum given is 80. So this is 20 and this is 80. This one. And then similarly for yw minimum, given is 40, and yw maximum is 80. So this is for those they have given the problem, and also they have given you the viewport values also, viewport coordinates also given. That is xv minimum is given 30, and xv maximum they are given 60, and yv minimum given is 40, and yv maximum given 60. So these values are 20, 80. Again, these values given are 40, 80, 40, and after converting or transforming from these values are known. These values are known. Okay. So how to solve this? Simple. First of all, you can find the fx value. You can use this equation. Then sy value. You use this equation and solve it. And then after that, you can solve directly instead of matrix. You can also solve on the x and y value, x and y value from a v. Suppose use equation number 1, equation number 2, and this 3 and 4. Okay. So first of all, I will solve the 3 and 4 equation. So for finding out Sx for this particular problem, 60 is so I will write first the equation. What is the formula for equation is Sx is xv max minus xv max minus xv min divided by xw max minus xw min. So so you can put the values. Here xv max is xv max given it is 30. Sorry, xv max given is 60. So 60 minus this xv minimum is 30. Okay, divided by xw maximum is 80. 8 minus xw minimum, that is 20. So you will get 30 by 60. Okay, 30 by 60. So this is the xx value. Then for sy value, sy equal to same, to use that equation, yv max minus yv minimum divided by yw maximum minus yw minimum. Okay. First we are using the viewport value divided by the window value. Okay. So in this v max yv max is 60 minus 40 divided by yw max is 80 minus 40. Okay. So sy will be 20 and this will be 40. 20 by 40. Okay. Then we will put these values of Sx and Sy in equation number 1 and 2. And then at number 1, I will write again xv equal to xv equal to this equation xv minimum plus xw minus xw minimum into Sx. So write down that equation xv minimum plus xw minus w minimum into Sx, right? Then xv minimum is 60, so 30 plus 30 minus 30 minus 30 minus, so this is your value 30 and this will xw, this will be xw value, so you have to use that 30 xw value 30 and 80. So in the problem they have given you the xw and y. They have given you xw value, that is 30, and yw value 80 given. Okay, so use that 30 minus this xw minimum is 20. Okay, so into this Sx value, this Sx value, that is 30 by 60. After solving this, you will get 35. Okay, so xv is 35. xv equal to 35. Find out the y by using equation number 2. Y is equal to yv minimum plus yw minus yw minimum into sy. Okay, sy value is 20 by 40. So y minimum is is 40 plus yw given, yw is 80 minus yw minimum 40 into with sy value 20 by 40. 20 by 40. Okay, 20 by 40. So solving this, you will get value 60. Y is equal to 60. Okay. Simultaneously, you can solve with me also. I will wait with you while. Okay. So in this way, final answer you have to write the point. So for the point of point on window, for the point on window given xw and value given xw and yw, that is nothing but will be so the remaining value, that is viewport value, that will be 35 and 60. 35 and 60, that is nothing but xv value and yv value. Okay, so in this way point clipping can be used to solve the problems. Okay, so some points are given to you with respect to x and y, and you have to solve this in this way. Now the second algorithm in this window and viewport. So there are three. That is, first is point, then second one is the line clipping, and third one is the polygon clipping. So we will move ahead for our line clipping algorithm. So it is called as nothing but Cohen-Sutherland algorithm. So name as Cohen. So line clipping algorithm. So it is a line clipping in algorithm. Okay. So I will show you here in this. Okay. Next line has a line clipping algorithm. So in this also you can see just a minute. Okay. So this is your okay. This is your window. So this point is called as XW minimum and YW minimum, and this corner point is called as XW maximum and YW minimum. Similarly, XW minimum and YW maximum, and XW maximum and YW maximum. And this is your clipping window. So inside the window, whichever the part of the line is inside this will be accepted by the by the program or by the computer or by the command, and the remaining portion of the line which is outside the window will be flipped. So we require flip. Okay. So there are various conditions are there. So four cases are there most probably. Then the first case is that the you can this line is entirely outside. Uh, the line is entirely outside, so it should be discarded. Okay. Then the second case line you can see it is completely inside. So it is completely inside the rectangle or the window. So it is accepted by the software. And then you can see here the portion, the third case is that some portion is inside the window and some portion is of the line is outside the window. So this is called as a partial inside right, and partial outside the window. Okay, partially inside and partially outside the window. So both, so you have to consider an intersection point over here, and then the remaining part you have to discard. Similarly, this fourth case in which two parts are outside and this three part is inside. So there will be two intersection points will be considered. Okay, and the remaining will be discarded. So I will write I will write first what are the conditions for the coincidental line keeping algorithm. Uh, then we will see what is this 000, this coding is there. So what is this PB, top, bottom, right, and L? Okay, what is the relation between this? We'll see. Okay, so first of all, I will do this and go back to the. Okay, so in this first you have to write. First you have to write the cases, the three cases, or the three possible cases, for this algorithm. So first case will be the line will be inside the rectangle, completely inside. If the line is completely inside the given rectangle or given window. Okay, then you have to accept. Then what you have to do? You have to accept that line. Okay, and no clicking is required. No clicking is required. Then second case will be completely outside. completely outside the given window. So you have to reject or discard. So no, in this case also no clipping is required. No clipping is required. So directly you have to discard that. In the third case, when it is partially, when it is partially, when it is partially inside the window, when it is partially inside, then you have to accept first. First, we require clipping. They require clipping. Then, after clipping, the remaining portion should be accepted. Should be accepted, which is inside the window. Inside the window. I will provide this notes over. Okay, I'm just explaining what is the basic concept. I will provide this and upload on the team. Okay, so just in case this Cohen-Sutherland algorithm will ask in the examination, they will have to write this all three cases, possible cases, and you have to explain with a simple example of solving this three cases in that example. So I will give one example over this. So how this will in seeing in the PowerPoint presentation, what are that 000 and 0 and all codings are there. So what are that? First we will see. Okay. So I will get back to that present. Okay. So you can see this. What is this 00 and all this coding? So which is you can see in the center 0000. So all if it is zero answer coming after solving it, if the answer comes 00, then it will be considered as the portion of that line or is inside completely inside the window. So first case will be applicable in this uh, case. Then next, if it is out completely outside, so that how much completely outside, then it can be rejected. And if it is partially inside and outside, then you have to use this coding and apply the and into this so that you can. So now how to get this 00 and all. So in this one term called TBRN. So that is nothing but top, bottom, right, and left. So this is used to plot these numbers. I will that how you can plot this. Okay. So in the center there is a window which is inside. So it will be 000. Okay. Then you have to plot the neighboring windows. So these are called as the neighboring windows. Neighboring windows. Okay. So in some time it is called as above, below, left and right. And in some cases it is called TBRL. That is nothing but T for top, B for bottom, R for right, and L for left. So it is nothing but top clipping, bottom clipping, right clipping, and left clipping. Uh, which is above this. So this is the top of this main window. This portion, this neighboring window is top. So in that case, you have to use the first port as 1, and remaining will be 000. Okay, so it will be 000. Okay, so first the top will be 1. Okay. Then for bottom, again the B, we in the B position, to write 1. So 0 1 0 0. This is your bottom. Then similarly for right, you have to use third one 1. Okay. Then for left, you have to use last one 1. Okay. Then after this, how to find out the neighboring windows of this TDRL? How to find out this? You can use OR operation between these two, OR operation between these two, operation between these two, and OR operation between these two. Hmm? So, and you can get here answer, here answer, here answer, here. So, in this case, if you apply this OR, so you will get this 001. I will write down here how you can apply the OR 001, and this one is 0100. So you will get 000, 011, 00, and 1. So write down that answer over here, 0101. Okay. Similarly, OR of this for this position, uh, 0010 and 0100. So this one and this one I used, and you can get 10110, 0110. Same for here. If you use, again I will write down that at 1001. Sorry, this will be the answer. 0001 and 10, you will get 1001. Okay, write down that 1001. The last or operation 1000 and 0010, you will get 1010. So 1010. Okay, so in this way we have how to find out that, or we can remember this. I will rewrite again. Okay, I will rewrite this again. Okay, first that main window 0000, then the neighboring one. So this will be TVRL. So 1000, bottom 0100, right 0010, left 0001, 010, 0110. Okay, so in the problem, they can ask you lines which will be the lines will be there and which will be rejected. Okay, so suppose a line is given in this way. This is one line, and second line is this is given. I will use another color that you can see. Okay, this is suppose one line P1 and P2. Okay, then another line is there P3 and P4. Sorry, all cases will be covered. Okay, I will use here. This will be the line P1 and the second line P3 and P4. This will be the next line 5 and P6. and the last another line is there here, that is P7 and P8. Okay, so such lines are then you can add this P1, P2 will be discarded, then the remaining in between this intersection point of P3 and P4 you have to kept, and P5, P6 will be completely accepted, and P7 and P8 in which the intersection point of their will be accepted. So how to write that the algorithm? Okay, so for this first starting with the first line, that is this P1 and P2. P1 and for P1 and P2. P1 and P2. So for this P1 and P2, you can see that it is suppose this is outside the orbit. So you get the point 0, 0, 0, 1, this pole, and then again 0, 0, 0, 1. So this is a non-zero answer. This is a non-zero, and by here you have to apply AND operation. You have to apply AND operation. Just where you hear OR operation for the answer, you have to apply AND operation. So for this 0, 0, 0, 0, 0, 1. So it is also non-zero. So in this case, which condition is applicable? That is a rejection condition. So if it can all answers are non-zero, then condition we have to use is reject the line, reject the line P1 and P2. Then next P3 and P4. P3 and P4. So again for this one code is coming 0, 1, 0, 0, 0 for this, and again I will write in this way. It will be more P4 will come 0, 0, 0, 1, and applying the AND operation you will get 0, 0, 0, 0. Okay, and operation you get 0. So the first one is a non-zero. Second one is also non-zero, but the answer coming in is 0. So it means that partially inside the window. It is a partially inside window. So you need clipping. You need line clipping. So for that, first you have to first intersection you have to mention over here and name that point as P3 dash. P3 dash. Okay. So name that point as P3 dash. Then and P3 will be discarded. Okay. In this case, P3 dash and P4 dash. You have to take P3 dash and P4 dash. P3 dash and P4 dash. Sorry, P4, P3 and P4. Again, the answer will come 0, 0, 0 for P3 dash, and this will be 1, 0, 0, 0, and operation you are getting 0, 0, 0. Okay, but one answer is non-zero. So again, clipping is required, and again you have to use here P4 dash. Now the answer will come 0, 0, 0. So you have to apply. So it is non-zero, 0, and this is 0. Okay, so you will get again clipping is again partially line is partially inside. So line, which line? P3 dash and to P4. The line is partially inside the window. Partially inside the window. So clipping is required. Clipping required. Again, you have to use that at P3 dash and P4 dash. P3 dash, I will write here P3 dash and P4 dash. So it is P4 dash. So you will get 0, 0, 0 and 0, 0, 0, 0. Again, the AND operation, you will get answer 0. So all are 0. So line P3 dash and P4 dash will be accepted. Line P3 dash and P4 dash will be accepted. So in this way, for the next line, that is P5 and P6, P5 and P6, P5 and P6, it is also completely inside. So after and also you get answer 0. So all are 0, 0, 0. So P5 and P6, P5 and P6 will be accepted. And for the last line, that is P7 and P8, P7 and P8, P7 and P8. Okay, so P7, we can see this. P7 is 0, 0, 0 and P8 is 0, 1, 0, 0. P7 is 0, 0, 0, 0 and P8 is 0, 1, 0, 0. So answer will come 0, 0, 0. So partially it is inside, but 1 is non-zero. So again you require clipping. I will not repeat again. So there will be an intersection point, that is the intersection point will come P7 dash. Now P7 dash, P7 dash 0, 0, 0, 0 and operation. Then the line P7 and P7 dash will be accepted. So in this way, sometimes they will ask you a problem over this, in which they will give you the coordinates of this line. Suppose the point P1 is at this point, P2 is at this point. You have to tell which line will be accepted and which line will not be accepted. So in this way, Sutherland algorithm of line clipping will be done. Okay, so any questions regarding today's session? In the next section, we will see the polygon clipping and how it works, and then we will start the third unit, is over the CNC programming, means CAM unit. Okay, any question regarding today's session? I will first download your attendance. Any question?
No, sir.
Okay. The batch B, today is batch A, I think, so practical session. For the practical session, I will teach you the part modeling in NX. And the assignment, first experiment on part modeling, you have to create the two parts and you have to take the screenshot of that. Rubrics how is also given in that. So you see that rubrics, how its marking is done. For each part, you will get 5 marks. For part modeling and as well as drafting of that, proper drafting. So all the terms and conditions are given in that rubrics. Please check that rubrics, how marking is done, and then you have to upload file. So file will be a PDF or a JPG file will be accepted. So in that file, part model you have to create and take a screenshot of that part, and in that screenshot you have to mention your name and roll number. Similarly for drafting also, in the drafting table or the title block, in which you have to mention your roll number and name, and all the so for B batch, I uploaded that assignment number one, and you have to submit I think in the September 5th, up to September due date is given, and after that date, your mark will be considered as zero. So you have to submit it as early as possible. Okay. So thank you for listening for the session. I will end this meeting, and for A batch, we will meet at 2 p.m. Thank you.